Okay, so today we are going to start October November 2021 paper 1-1. Let's start with question number 1. The mass spectrum of a sample of a neon is shown. The relative abundance of each peak is written in bracket above it. Okay, so in these brackets over here, there are the relative abundances. What is the relative atomic mass AR of the sample of the neon? So I think it would be very easy to calculate. AR is equals to 20 times 100 plus 21 times 0.3 plus 22 times 8 over 108.3, because in numerator we would take the uh, sum of the abundances. So can anybody calculate and tell me the answer, please? Yes, can anybody do the calculation and tell me the answer?
$20.15.
It's 20.15. Okay. Okay, 20 into 100 and by adding the relative abundances, Naveen. Okay, do one more thing over here. I just want to check. For example, if it's 20 times 100, okay, and 21 times 0.3 into 22 times 8. And instead of 108.3, if you divide it by 100, then what is the answer you are getting? Just tell me. For this 20.15, so according to this, it can be an answer. But uh, tell me this one as well. Will be the answer if we do the calculation in this way? Putting the 100 in the numerator, denominator, sorry.
सर आपकी आवाज बहुत कम कम आ रही है.
Now is it clear?
यस सर. सर अपॉन 100 क्यों करें?
I just want to check what is the answer I'm getting now. Because the relative, whenever we do, we not usually take the relative abundances, the sum of the relative abundances in the denominator.
So, सर आपने बीच में भी मल्टीप्लाई लगा दिए प्लस हुआ।
Yes.
सर 3.823 आ रहा है।
What is the answer you are getting now?
3.823।
No, you did some mistake in the calculation. Do it again. It is not possible that you will get 3 point.
सर 21.823।
Now you are getting 21.823, right?
जी सर, जो शुरू वाला 20 था ना, उसको मैंने गलती से 2 ले लिया था।
Okay. Okay. So your answer would be A. And remember what we need to do. We have to remember whatever these values, the uh, abundances are given to us, we will always keep their sum in the numerator, in the denominator. Okay. Now, question number 2. 2 grams of ammonium nitrate and H4NO3 decomposes to give you 0.90 gram of water and a single gas. What is the identity of a gas? Okay. So, can anybody just quickly calculate the MR of ammonium nitrate? It's 14 for nitrogen, 14 plus 4 gives 18, 18 plus 14 plus 48. Isn't, is it 60? No, 48. Yeah, it's 80, right? So the moles of ammonium nitrate that is used in heat is 2 over 80. Can anybody calculate the moles? In the same way, here we have a water. The MR of water is 18. So the moles of water formed over here is uh, 0.9 divided by 18. Yes, can anybody tell me the values of the moles of water and the ammonium nitrate, please?
सर अमोनियम नाइट्रेट का है 0.025।
0.025, okay.
सर वाटर का है 0.05।
0.05. So if you compare the ratio, isn't it that if I whatever the moles of ammonium nitrate would be, the water would be forming the moles of water would be double than the moles of ammonium nitrate, right?
यस
There
सर।
are 0.025 moles of ammonium nitrate and the water moles of water would be 0.05. So it means if instead 0.025 there is a 1 mole, so the moles of water formed would be 2. Yes, is this part is understandable to everyone?
यस सर।
So if I write the equation of decomposition of ammonium nitrate, 1 mole of ammonium nitrate is giving me 2 moles of water. If you try to balance this equation in this way, so if there are 2 moles of water, are formed, then if you look over here, we are left with two nitrogen atoms and one oxygen atom. So it would make it N2O. So the gas that is produced would be N2O. According to that, A, B, and D goes wrong, and C will be your correct answer. Yes, is this understandable to everyone? If anyone have any doubt to ask, please. Yes, is this question is clear? Okay. Which of these elements has the highest fifth ionization energy? Okay. Highest fifth ionization energy. So if you look, if you will find them in the periodic table, so there is a group 14 and group 15. In group 14, there is a carbon over here and nitrogen over here. And then there is a phosphorus over, sorry, there is a silicon over here and phosphorus over here. So if you look at silicon and phosphorus, as silicon and phosphorus belongs to period 3 and carbon and nitrogen belongs to period 2, this makes phosphorus and silicon cannot be an answer of being the highest ionization energy because already they have a more shells. So the electrons are further away from the nucleus. Is this point is clear to everyone? Now we are left with the carbon and nitrogen. So we have to decide whether carbon or nitrogen, which one have a highest uh, fifth ionization energy, which means when their fifth electron is actually lost from the valence shell, needs the highest amount of energy. Yes, so whether it can be a carbon or a nitrogen.
Carbon, sir.
Why, Nuria?
Because high energy is needed.
How you justify this if you are saying carbon? And if you are saying nitrogen, you have to justify how nitrogen as well. Yes. Okay. The reason is if you compare carbon and nitrogen, the fifth ionization energy of carbon would be higher than nitrogen. But if you have to explain, see, nitrogen is in group 5. So it means 5 electrons in valence shell, right? And in case of carbon, 4 electrons in valence shell. So for carbon, the 5th electron is, its valence shell is second, and the 5th electron that we have to remove, that 5th electron is in first shell over here for carbon. So which is more closer to nucleus. And and in the case of nitrogen, the 5th electron is in the second shell only. So which is actually at a distance from the nucleus as compared to the 5th electron that is being removed from carbon. So that's why nitrogen's 5th ionization energy would be lower than the 5th ionization energy for carbon. So that's why A will be our correct answer. Is this clear to everyone? That in case of a nitrogen, all the 5 electrons in the second shell, that is their valence shell. So the 5th electron is removed from the second shell for nitrogen, but for carbon, when we have to remove the 5th electron, that actually is in the first shell, which is even more closer to the nucleus, which makes which makes it to, we have to provide a larger amount of energy to remove that electron. That's why A would be the correct answer. Now, question number 4. The ion X2 positive has the same electronic configuration as the krypton. Okay. What is the electronic configuration of the atom X? Okay. So atom X would have 2 more electrons than krypton. Right? So first look at krypton in the periodic table. That what is the atomic number of krypton? Here is a krypton and its atomic number is 36. Okay. So here 36 electrons and X2 positive have 36 electrons as well. So it means atom X have 2 more electrons, which have 38 electrons. Okay. So if you look at argon in the periodic table, the 18 electrons are over here. Okay. So from 18 to 38 electrons we have to fill. Okay. So if you count from here, 18 electrons over here, 19, 20, then 20, 30, and 36 electrons. But we need to show the electronic configuration till 38 electrons. So A is wrong. Now 18 electrons still over here. Then after we have a 4s2, after 4s2, 3d10, 20, 20, 30 electrons, then 3p6, 36 electrons, and then 2 electrons, 38 electrons. That can be an answer. Here, 18 electrons, 4s2, 20 electrons, 4d10. This is wrong. After 4s, 3d would fill, as what we have discussed in the atomic structure. So C goes wrong. After, remember, 4s, not 4d will fill. First 3d will fill, then there will be a 4p. So in the same way, here there is a 4d, so this goes wrong as well. So your correct answer will be B over here. Is this clear? Yes, if anyone have any doubt, please ask. Yes, is this clear to everyone? Now question number 5. Which type of interaction exists between water molecules and metal cations in aqueous solution? Okay. So if you look at a metal cation, so it can be any metal having a 1 plus and a 2 plus charge. And if we look at a water molecule always in a bent shape. And if water molecule attracts the cation, then the partial negative oxygen would attract the positively charged cations. So the attraction is between the oxygen of a water molecule and the metal cation, right? So first option says dipole-dipole interaction. Second option says hydrogen bond. So hydrogen bond is clearly wrong because there is no hydrogen in the cation, right? In the same way, ionic bond is also completely wrong because for ionic bond, there must be both the ions which are attracting each other. Now we are left with A and D. D says ion dipole interaction. So yes, see, this molecule have a dipole and here we have an ion, right? So we can call it ion dipole interaction. So A goes wrong and C is your correct answer. Is this understandable to everyone? Now, question number 6. Which substance shows the greatest deviation from the properties of an ideal gas under room conditions? Okay. So, if you recall, if there is any gas which can show deviation from the ideal gas, is the one which have a strongest intermolecular forces. And if you look at carbon monodioxide, there is the known at dipole. So there is only induced dipole, temporary dipole forces. In hydrogen, there is induced dipole, temporary dipole forces of attraction between the hydrogen molecule. In neon, again, it is the same induced dipole, temporary dipole forces of attraction. But in ammonia, there is a hydrogen bond, right? And hydrogen bond is the strongest bond or strongest intermolecular force among all the intermolecular forces. So ammonia gas can show the greatest deviation from the properties of an ideal gas. So the correct answer would be D. Is this clear to everyone? Yes, if anyone have any doubt, do ask. Now, question number 7. In order to determine the enthalpy of neutralization of a strong acid and a strong alkali, 25 centimeter cube of 2 mole per dm cube sodium hydroxide is added to 25 centimeter cube of 2 mole per dm cube hydrochloric acid. The increase in temperature is 12 degrees Celsius. So, okay, what information they have provided us that for sodium hydroxide, 25 centimeter cube volume is used and the concentration is 2 mole per dm cube. In the same way, the hydrochloric acid used, its volume is 25 centimeter cube and its concentration is 2 mole per dm cube. And the change in temperature for this reaction is 12 degrees Celsius. In second experiment, the same method is used, but 50 centimeter cube of 2 mole per dm cube sodium hydroxide is added to 50 centimeter cube of 2 mole per dm cube hydrochloric acid. Okay, what is the increase in temperature? So here what they have used, instead of 25 centimeter cube, they have used 50 centimeter cube. The concentration is again same. For sodium hydroxide, in the same way, they have used 50 centimeter cube of hydrochloric acid and the concentration is again same. Now what they are asking, what will be the change in temperature? Yes. Yes, can anyone suggest what would be the change in temperature? Yes, can anyone suggest, please? See, there is an equal concentration. The volume is just gets doubled, right? So change in volume, we are using the more volume, but that more volume doesn't, make any difference because there are more moles now. So the change in temperature that you will get over here would be the same as previous case. It would be the 12 degrees Celsius still. So A, C, and D are wrong, and B will be your correct answer. Okay. Now question number 8. Which equation represents the enthalpy change of atomization of iodine? Okay, for enthalpy change of atomization of iodine, for case of atomization, you must remember that it can be in any case in which element turns into gaseous atom and the quantity of that gaseous atom would be 1 mole. So if you look at over here, there we need a 1 mole, right? So on the basis of this, I can mark B and D wrong. Now I am left with A and C. So if we talk about iodine, iodine exists as a solid, right? Not a gas. So A goes wrong and we are left with the correct answer, that is C. Is this part is clear to everyone? Now, question number 9. Zinc atoms can be oxidized to zinc 2 positive ions by dichromate 6 ions in acid solution. Chromium is reduced to Cr3 positive in this reaction. Right equation. Which equation is correct? Okay. So what they have told you, you can do in this way as well. I think which will makes it easier. That zinc is turning into zinc 2 positive. So it means how much electrons are lost? 2 electrons are lost. So you have a 1/2 equation over here. In the second equation that they are saying that there are dichromate 6 ions. 1 minute, yes. Dichromate is Cr2O7 2 negative and it turns into chromium 3 positive ion as they have told you. So if you work over here, get the charge or oxidation number of chromium is +6 and there are 2 chromium. So it means that we need a 2 chromiums over here as well to balance these chromium. So if you look over here, there are 2 chromiums, each chromium have a +3. So here the charge would be plus 6, and here the charge would be plus 12. So we can say that 6 electrons are gained. Is this understandable to everyone till here? That dichromate is gaining 6 electrons and 1 mole of zinc is releasing 2 electrons. Yes, is this part is understandable to everyone? Yes. So what I need to do, I need to balance the electrons. If the 6 electrons are being gained, then 6 electrons must be being released as well. So to release the 6 electrons, I have to multiply the first equation with 3. So if I do this, we get 3 zinc, and as a result, we get 6 electrons being released. Now, if you see, six electrons are released, 6 electrons are gained, it got cancelled. You are left with 3 moles of zinc reacting with 1 mole of dichromatine, forming 3 moles of zinc 2 positive and 2 moles of chromium 3 positive. Now have a look at the equation. We got the ratio that 1 dichromate is to 3. So A goes wrong because this ratio is wrong. In the same case, in B, the ratio is again wrong. If you look at in D, the ratio is again wrong. So the correct answer is C. Is this understandable to everyone? Yes. If anyone have any doubt to ask. Okay. Now for 10, the equation shows that hydrogen and iodine gas reacts to an equilibrium. Okay. At temperature T1 and the composition of the mixture is monitored, a graph of the result is shown. Okay. The mole fraction, initially the mole fraction of iodine 5 and helium, the mole fraction decreases to 0.3, which means that change iodine concentration 0.3 in the mole fraction would be, sorry. So the change would be 0.27. Okay. The experiment is repeated at lower temperature T2. The new graph would be obtained. Okay. Which new graph would be obtained? Okay. Which new graph would be obtained? Yes. Any suggestions from you guys? You can try to answer the question with the justification that which would be the correct answer when we lower the temperature. What? Okay. First thing is that C cannot be an answer. Why? Because the temperature gets lower, so the gradient would not be the same as the initial temperature or as the initial graph that is provided because lowers the temperature would lower the rate. Okay, that is the first thing. And if you look at the reaction, the enthalpy change is exothermic, right? So remember, if you decreases the temperature for the exothermic reaction, the equilibrium shifts to the right. Actually, lowers the temperature, shifts the equilibrium towards the endothermic side. And here in this case, the endothermic side is the product side. So it means more product would form at the lower temperature. So initially, if we are getting this much decrease, then at lower temperature, the decrease would be more greater. And if the decrease would be more greater, so D goes wrong because D have a lesser decrease. A would go wrong because A have a equal decrease as the initial case. If you look at B, the gradient is lower, which is showing that the reaction is occurring at the lower temperature. So the rate would be slow, but we will getting the more amount of the product as the reactant is decreasing even more when the equilibrium is established, because at lower temperature, equilibrium shifts in a direction which is the endothermic. So it means B is our correct answer. Yes. Is this question is understandable to everyone? If anyone have any doubt till here, kindly ask. Yes, is this question is clear till here only, and tomorrow inshallah we will continue the session and we will do the rest of the questions from this past paper. Okay. Okay, then take care everyone. Allah Hafiz.